Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. An honor to meet you in this beautiful day. Thank you for coming to this presentation. We would like to share about our research paper. Let us introduce ourselves. I am Assyfa Zahra Wijayanti, and next to me are Asih Sabila, Jari Badri, Tika Kramelia, and Fildjah Apriliani Mayendri. We are on behalf of our team, Nuphan ilyas, and Komariah, and Dedy Achmad Kurniadi. In this opportunity, we would like to present our research paper entitled Using Computer Tools to Improve the Teaching Learning Process in Vocational Education, the field of Pharmacokinetics. Pharmacokinetics is taught within the pharmacy curriculum with a focus on basic concepts and definitions, together with a description of the common mathematical models. For clinical pharmacy, mastery of pharmacokinetics is crucial since it is used to estimate optimal drug dosage regimens in different therapeutic situations, specifically in the context of TDM. Better knowledge and understanding of pharmacokinetics may also play a role in the avoidance of medications errors due to inappropriate dosage recommendations, which can either occur due to overdosing or underdosing. In Indonesia, about 17,357 medication errors were reported between 2009 and 2012, and 76.1% of these were due to prescribing errors, which include errors in dosing. Errors concerning TDM, for instance, can occur in various forms. First, a clinician ordering TDM when it is not indicated. Incorrect sampling times, errors in drug concentration analysis and pharmaceutical terms, also incorrect interpretation of data and the subsequent inappropriate dose recommendations. Pharmacokinetics is a subject that is often not well received by students due to its basis in mathematics and difficulty in linking basis concept with clinical relevance.
One way to tackle this issue is by incorporating innovation to improve study and understanding of the subject. Four strategies have been adopted to improve the learning experience, including pharmacokinetic based on games to help students learn theory and application. Such a learning enables students from geographical diverse population to pursue further education, using technology to allow team-based learning despite the distance. The use of pharmacokinetic-based computer program may also help students to achieve a better comprehension of pharmacological concepts. Visualizing the effect of changing pharmacokinetic parameter in patients via corresponding time concentration curves and allow them to have a better application of computer utilization in clinical practice. The use technology-based learning is also suitable with new generation of learners or millennial style of learning. They are more likely feel comfortable with multimedia use. Therefore, educators must evolve and innovate to better complement the new generation of learners as the technology of computers and smartphones offer exciting opportunities to be utilized in pedagogy. Pharmacokinetic software that are readily available must tend on to focus on either specific TDM calculation or pharmacokinetic modeling with a small proportion focused on bioequivalence. Commercial software is often expensive and not focused on the aspect to teaching and learning and unsuitable for our purpose. Thus, the current system attempts to combine all these areas, including core pharmacokinetic parameter calculation with multi-dose application to TDM and bioavailability together with learning models to produce, unlike as existing software and all encompassing system designed for teaching and learning. The inclusion of pharmacokinetic database conspires from the real patient data may help students to understand the variable in pharmacokinetic parameter of the same drug among patients with varying ages and health conditions.
The materials and method in this paper is the program was written in the Java language, a general-purpose high-level object-oriented cross-platform programming language developed by Sun Microsystem using NetBeans IDE version 8.2 and CAL package was developed using Adobe Captivate 2017. The modular approach will allow the inclusion of Wagner-Nelson methods for a calculation of oral dose absorption rate constant. if this internal consistency check fails. TDM calculations were written by following the Malaysian Ministry of Health, or MOH, TDM guidelines. This is a crucial point, as the software will not be placed on general release until it has been validated and approved by the MOH. The aim here is to prevent its use in a clinical setting, with particular reference to the TDM modules. Until then, it will only be available from university servers and will not be provided to students as a standalone application. Data collection was done in Hospital Putrajaya, or HPG, from November until December 2017, from the Pharmacy Department TDM registry. Data recorded by the Pharmacy Department between 2015 and 2017 was used to construct the database. No patient identifiers were used, and each patient was anonymized by being assigned a unique patient ID. The target sample size was approximately 884, and this was rounded up to 400, divided between the three drugs for the TDM modules, with 200 for gentamicin and 100 for vancomycin and phenytoin each. This division was based on the availability of data from the HPG TDM registry. And next will be presented by Fildjah.
Unit testing was conducted for each function in the software using specifically prepared test cases to check accuracy. After completing unit testing, the testing process moves on to integration testing, specifically to ensure the correct flow of information between modules in the database. System testing was conducted with the help of a third party using a test case prepared with the assistance of a certified software tester and a registered pharmacist with prior experience in software testing. No major errors were discovered in this stage. Validation of the calculation for modules involved comparing calculated parameters with manual calculation and graphs generated using Microsoft Excel. For manual calculation, the graphs were manually drawn and the graphs gradients and intercepts were determined and used for further calculation. It was noted that the values obtained from the software calculations and Microsoft Excel matched each other well, but there were slight differences between the output and the answer obtained by manual calculation, particularly in the oral module not shown. For a final validation step, multiple values of Q were compared between those from the software, Microsoft Excel, and manually calculated values, and the second set of data compared the values produced with calculation made by HPJ pharmacists for the TDM modules. The first set of data compared 14 values of key produced by the automated graph models against the values obtained by Microsoft Excel and manual method. The second set of data compared 20 values of key produced by the automatic calculation module and calculation made by HPJ pharmacists. 10 values were randomly selected from the gentamicin database and 10 values from the vancomycin database using an online randomizer. The values of key produced completely match. For comparison, 3 types of analysis were performed: correlation analysis, paired sample t-test, and blind Altman analysis. It turns more than 80% of respondents expressed satisfaction in 9 of the 10 times, except item number 9, which assessed satisfaction on the voices and sounds used the CAL modules.
The program was validation by performing unit, usability, and end-user testing. Unit testing of function was conducted from the early stage of software development and was done on each function upon completion. Completed modules were combined and then integrated tested, evaluating the communication between modules and the database. Independent system testing was also conducted by 2 software testers not involved in the development of the project, a certified software tester from the College of Computer Science and Information Technology, University Tenaga Nasional, and a practicing pharmacist with experience in conducting functionality tests for pharmacy information system. To assess usability and user satisfaction, a user satisfaction survey was conducted among end users via a validated 3-section questionnaire. The sample size of 170 was calculated using a Cauchy and Morgan 15 equation of third-year undergraduate University Technology Mara pharmacy students. The target population was allowed to try using a software through a standardized assignment to exercise, in which students were given pharmacokinetic and TMD-related questions that needed answering with the help of the software. The first section of the questionnaire collected basic demographic data, followed by section 2 consisting of a validated 10 items, 5 points Likert System Usability Scale or SUS, developed by John Brook for Digital Equipment Corporation. The third section was used to measure user satisfaction in terms of GUI, output, the CAL module, graphics, and sound use, as well as general capability.
Conclusion: a modular pharmacokinetics computer program was successfully developed using Java and the NetBeans IDE version 8.2. Java was chosen as it allows portability between devices, where the same source code can be used for different operating systems, including Windows, Mac OS, and Android. Consisting of 3 main components, which is an automated calculation module, a pharmacokinetic database, and a CAL module. Each was structured to assist students to understand pharmacokinetics, from content delivery, calculation assistant, a database to give access to various pharmacokinetic profile and student-based activities for teaching and learning. 3 levels of software testing were completed: unit testing, integration testing, and also system testing. A user satisfaction directed at mainly third-year pharmacy undergraduates revealed an average usability score of 68.8, indicating good usability. From the data, we can know that the end user were generally satisfied with the software in its current state and provided good feedback and recommendation for further improvement. The next step are to further optimize the program and to introduce the software package to students during undergraduate teaching, in an attempt to augment lectures and tutorials and allow students to gain visual validation of their manual calculations. Thank you very much for your great attention, ladies and gentlemen. We also thank for listening our research presentation. May all those we have shared could be beneficial for all of us. Wassalamualaikum warahmatullahi wabarakatuh.